Okay, so for question 5, right, part A, I will not be going through in detail. Part A is just pi RL. So you just need to know where is the pi RL. So this is the 8, this is the 5.5. You got to do a Pythagoras to get your L. So usually most students will be okay to do a pi RL. Okay, the issue is here. Some people didn't know how to explain. And this one, I'm going to relate it to your emath, okay, in a short while. Okay, so in this question, right, okay, from 8 centimeter, so originally the height is 8 centimeter. So right now, 2 centimeter amount of water is taken away, and this person thinks that it is 75% of the capacity. So it is wrong because the radius also got reduced. The radius is not being constant. So the radius is also being reduced. So at the same time, the height is reduced. The radius is also being reduced. Okay, so the radius should also be reduced by 25% because the height is reduced by 25%. So can see the height is reduced by 25%, but because the radius is also being reduced by 25%, so the volume should be reduced by more than 25%. So that is the idea. If let's say it is not a cone, right? If it's just like this is an 8, and then you reduce it, then you will be all right. The volume will be subsequently reduced by 25% because nothing changes. The height just get reduced by 25%. Okay, but in this case, right, that's not the situation. The radius is also reduced. Okay, so this is an explanation part that a lot of people couldn't explain. They will say that it's so obvious that it's not 75%, but they can't explain. Okay, so if you will need to calculate the percentage of the capacity of that is filled, you should use similar triangle. You should use similar ratio. So this will happen in your emath as well. In your emath rate of change, if you got a cone and if you got water, you got to execute similar triangle. I can't remember, is it 13? 13, you did ask me for, I know sometimes 13 you ask me question, right? Then you ask me for hint. I think one of the emath question you did ask me before, it is a hint on this kind of diagram. So this is a kind of diagram that involves similar triangle in emath, but then they will not tell you, they will not specify that it is emath, it is similar triangle. So you just need to execute the similar triangle part. Okay, so this one you got to apply similar ratio. So where does the ratio come from? So the ratio will come from the height. So this is the ratio, this is a similar triangle. Okay, I think I didn't draw nice enough. So where are the two similar triangles here? The small one in the middle and the bigger one here. So this will be the similar triangle. And using that, right, the height ratio is 6/8. The height ratio is 6/8. Can see the similar triangle involved. So once you found that the height ratio is 6/8, that means how much water is inside. That means water versus the glass should be 6/8 cube. So from here, you can calculate the percentage. So you do not need to calculate the actual capacity. Some of you may have gone and calculate the actual capacity. So the percentage of water is just the ratio times 100%. So that's it. Okay, so I think if you see this is 2 marks, right, please don't go and calculate the radius. Some people calculate the radius using similar triangle, calculate the volume of the glass, calculate the volume of the water. It is feasible, but you will feel that you are doing too much for you are doing too much working for 2 marks. Okay. So from here, you're going to pour the amount of water into the glass. So this is the real time that you actually need to calculate the amount of water. Okay, so you need to calculate the original. Okay, so the original will be, okay, I can't remember. Oh, this is 5.5. So you got to calculate the original volume first, which is 1/3 pi r square height. And then with this, make sure you remember that it's not all filled up. So it's only a certain percentage filled up. Let me get the answer for the previous part. So it's only 42.2% filled up. So you calculate the full volume, then you use this ratio to calculate the amount of water. Did I calculate correctly? Is it 8? Yeah, correct, 8. So this will be the amount of water. A bit of mensuration involved, and then from there you will get this amount. Okay, don't press out the pi. That's not the final answer. Try to preserve it. And then, right, you're going to pour it into a cylinder. So when they pour it into the cylinder, the depth is 2.5. We are interested to find the radius. So pi r square height is equal to this amount of water. Okay, the reason why you keep it in pi so that you can do the cancellation. And then you go and work out your R. So this question marry the volume ratio, also marry a bit of mensuration, the volume.